Hey guys, this video is for the people that had trouble with the Ionic formula puzzle problem set. You were looking at a table that looked like this, and the whole concept behind this activity was to combine ions in order to form an ionic compound. So just as a recap, remember that an ionic compound is made up of two parts. You have a cation and you have an anion. The reason that they come together to form a compound is because this one has a positive charge and this one has a negative charge, so they are attracted to each other by what we call electrostatic forces. This is what I covered in the nomenclature lecture about 2 days ago or 1 day ago. I do not remember what it was. But all you're looking at is this table, and they tell you which two ions you're looking at. So in all of these examples, they give you the cation first, so just know that each of the elements that are listed first have a positive charge. So aluminum has a positive charge. The one that's on the right will have a negative charge. So we have chloride. Okay, so I've done this example with you guys during class, but in case it hasn't really clicked for you, we'll look for the first element, which is aluminum, and I'll have to use my laptop to look at the table because I forgot to bring a printout home. So if you look for aluminum, you will see that it is in the third period right here. Sorry, not period, in the third group in the periodic table. Because it's in the third group, it's going to have a positive 3 charge. So the 3 comes from the, because it's in group 3. So it'll have a positive 3 charge. So what I can write in this sheet right here is Al plus 3. Just so that I have in my mind that aluminum has a positive 3 charge. The second one is chloride. Now what I told y'all in class is that if your second ion, so your anion, ends in "ide", that means that you're looking at just one atom of that specific element. So in this case, our element is going to be chlorine. How did I know? Well, because it starts with the same letters, chlor. So this is chlorine, that's the element. Chloride is the ion. And that just comes from our nomenclature rules. Anytime you are naming an ionic compound, the first word is the name of your cation, so your metal, which in this case is aluminum. The second word, so aluminum chloride, the second word is your anion plus, so the first letters of your anion plus IDE. So that's how I know I have this right here. If it's IDE, again, you're looking at just one atom. We'll talk about polyatomic ions down here. So now if I look for chlorine over here in my periodic table, I can see that it's under group 7. Group 7, I told y'all, has a -1 charge. So any element from here will have a -1 charge. As you move over to the left, these will have a -2. These will have a -3. And then the fourth group doesn't really give us any ions. So as you start from over here, you have +1, +2. We skip the transition metals, +3 in group 3. And then we start from over here, -1. Sorry, not the noble gases, but right here, the halogens. We have -1, -2, -3. So I know that chlorine has a -1 charge. How do I know? Again, I can just memorize that the halogens have the -1. These right here have the -2. These right here have the -3. Another reasoning for this is that the group number gives you how many valence electrons these have. And then we talk about something called the octet rule, which is that all of these elements want to get to 8 valence electrons, which is what the noble gases have, so that they can become stable like the noble gases. This one right here just has 7. Therefore, it's going to try to get one new electron, and so it's going to have so any one from this group is going to have an overall charge of -1. So these would have a total negative charge of 1 because they gain an electron in order to get 8 valence electrons. These are in group 6, so they would try to get 2, so they would have a -2 charge. These are group 5. 5 plus 3 is 8, so they would try to get 3 electrons, so that would be a total negative charge of 3. So now, this right here, what you do in this part, if I know that, let's say this is my aluminum atom, I'm going to say Al. Now I know that my aluminum atom brings in a positive 3 charge. So I'm going to draw 3 plus signs, and that's just from one atom. Then I know that chlorine has a negative 1 charge, so just one negative. Okay, that just has to do with how many valence electrons they have and how many they will either lose or gain in order to satisfy the octet rule. Okay, so this one has 3, this one has 1. This one's positive, this one's negative. Right now, my overall charge, I have a negative 1 here, and I have a positive 3 here. If you combine those two, that's going to come out to a overall charge of +2. When we are combining ions to form ionic compounds, we do not want any type of charge. We do not want a positive charge or a negative charge. We want this to be 0. How can I solve that? I have to add 2 more negative ions here so that this will be a total of -3. And then we'll have +3 -3. We'll finally get the 0 charge that we want. Okay, so in order for me to do that, I'll keep this the same because I don't want to add more positive charges because I already have enough. I already have too many. So instead what I'm going to do is I'm going to bring 2 more chlorine ions. And now I have 1, 2, 3. That's a total of -3. That's what we wanted. So now our compound is neutral. So for you to form an ionic compound with aluminum and chlorine, and for it to be neutral, you will need 1 aluminum and 3 chlorine. This 3 no longer represents a charge. This is a subscript. This is telling me how many atoms of chlorine I'm bringing in. So now I have aluminum chloride. There's no subscript for aluminum because there's only 1. Anytime you have just 1 of something, of an atom, you don't have to write the subscript.